Hello again. This is our last lesson in this unit. It is lesson 5.13 on valid arguments. So let's do this. We're going to, as usual, define a few things. We're going to say that an argument is the set of propositions called the premise. And that's going to lead to a final proposition, which is called the conclusion. And the conclusion, you can tell where it is because it's usually got the word therefore or hence in it. So an argument is going to be said to be valid if and only if the premise correctly implies the conclusion. And we're going to show how to use truth tables to do that. So let's start off with a simple example. Premise 1 is that if I eat spoiled food, then I will get sick. Premise 2 is that I actually do eat spoiled food. So the conclusion is, therefore, I will get sick. So kind of a simple example, but it's going to make it easier to see how the process works. So I need to show that premise 1 and premise 2 imply the conclusion C. So I'm going to let proposition P be I eat spoiled food. Proposition Q is going to be I get sick. And so this is what I'm trying to show. Here's premise 1 represented as P implies Q. I eat spoiled food, then I get sick. Premise 2 is just proposition P, I eat spoiled food, and the conclusion is just proposition Q, which is I will get sick. Okay? So I need to show that this P implies Q and the P both imply Q. And I should be able to look at a truth table and get truths all down the last column of that truth table. So let's draw it. Here's P, here's Q. I'm going to put P implying Q here. Then I'm going to put P implying Q and P. And then in the last one, I'm going to see if that implies Q. So if they're both true, pretty much everything is true. If P is true and Q is false, remember P implies Q is false. That's the only time when P implies Q is false. So that and P gives me a false. So that false implying Q is a false implying a false. Well, that's true. Okay. Now, if P is false and Q is true, then P implies Q, that is true. So that truth and P, which is false false. So that false implying Q, which is true true. Okay, and in the last row we've got false and false. So P implying Q, that's true, and that truth and the falseness of P is false, but that falseness implying Q, which is false, is true. Okay, so I've got all truths in the last column, so what that means is I've made a valid argument. Okay, let's look at a more difficult example. All squares are rectangles. All rectangles are quadrilaterals, therefore all squares are quadrilaterals. You may have learned this as the law of syllogism. That's pretty much what I'm using here. And so I need to show that premise 1 and premise 2 imply the conclusion C. So I'm going to use proposition P being it is a square, proposition Q being it is a rectangle, and proposition R being it is a quadrilateral. So premise 1 can be written as P implies Q, premise 2 can be written as Q implies R, and the conclusion can be written as P implies R, just making those substitutions of sentences for letters. So I need to show that P implies Q and Q implies R implies P implies R. I need to show that that's a tautology, meaning all truths in the last column. So here we go. It's a bit of work. I'm going to put P and Q here and R here. I'm going to put P implies Q here. That's the first set of parentheses. And Q implies R here. That's the second set of parentheses. And then I'm going to use the AND operator between them here. That's going to take care of using the AND operator on those first two sets of parentheses. Then I'm going to use the last set of parentheses, P implies R. That's going to be my red. And then in the very last one, I'm going to see if blue implies red is true. So that's basically going to go all here. So first off, they're all true. That means that P implies Q is true. That means that Q implies R is true. Using the AND operator on two trues is true. P implies R is true, so everything is true. That first row is usually pretty easy to fill out. Now let's see what happens if R becomes false. P implies Q is still true, but Q implies R is false because true implying false is false. That's the only time it's false. So the AND of those two previous columns, the true and false is false. P implies R, that's false because again I've got another true implying a false. And so false implying false is true. Okay, now let's see what happens if only Q is false. That means that P implies Q is false, Q implies R is true. The AND operator on that false and that true gives me false. P implies R is true. False implying true is true. And if both Q and R are false, then P implies Q is false, Q implies R is true, P implies Q and Q implies R is false because I've got a false and a true. P implies R is false, and false implying false is true. And you go through all of the columns using all of the rules that you've learned about the truth tables. And so hopefully what we get is trues in every cell in the last column. And in fact, that's what we actually get, even if all of them are false. That's what we get. So if we get all trues in that last column, then I know that I have a valid argument. So that is making valid arguments using premises and conclusions, and showing that those arguments are valid using truth tables. So if you have any questions for me, let me know, and I will see you tomorrow.